Ever wondered if your diesel engine can blow bigger bubbles than a gasoline engine? Today, we're putting that to the test. We're diving into the science of exhaust pressure, low-end torque, and RPM using a simple yet effective experiment: bubble blowing. Our contenders are two types of engines, a KM178FD15 diesel engine and a 713 horsepower gasoline engine. The key to this experiment lies in the exhaust. We'll use a classic soak cup setup to capture the exhaust and inflate bubbles, giving us a visual comparison of exhaust pressure. First, let's talk about RPM. RPM, or revolutions per minute, is how fast the engine's crankshaft spins. A higher RPM generally means more power, but it doesn't tell the whole story. Next up is low-end torque. Torque is a twisting force, and low-end torque is the torque available at lower RPMs. Diesel engines are known for their high low-end torque. Let's start with the diesel engine. As we increase the load on the diesel, it generates more exhaust. The exhaust pressure builds, and this allows the diesel to blow larger bubbles. The increased exhaust pressure is directly related to the high torque output, especially at lower RPMs. This means more force to push out exhaust. Now, for the gasoline engine, we'll follow the same procedure. Under load, we'll observe the bubble size. Gasoline engines, while capable, may not produce the same bubble size under similar loads as the diesel. Their torque characteristics are different. The gasoline engine's peak torque might be at higher RPMs, so its exhaust pressure won't be as high at the lower RPMs. The main reason why the diesel might win the bubble blowing contest is its inherent design. Diesel engines generally have a higher compression ratio than gasoline engines. This results in a more powerful combustion stroke. When the engine is under load, the combustion is more forceful. This leads to higher exhaust pressure, which is what we use to blow those big bubbles. So, what does all this mean? The diesel engine, with its higher low-end torque and higher compression ratio, is likely to produce bigger bubbles under load. This visual comparison isn't just fun. It illustrates fundamental engine characteristics. In summary, the size of the bubbles is directly related to the exhaust pressure, which is, in turn, related to the engine's torque and RPM characteristics. Diesel engines often excel in this area, blowing larger bubbles due to their design and higher torque at lower RPMs. Thanks for watching. Hopefully, you learned something cool about engines and the science of bubbles.